Good morning, everyone. Welcome to day 2 of EOCP2021 conference. I hope you enjoyed this morning's sessions, and we're happy to have you back. This is the wastewater stream, and it's our session from 10:15 to 11 is with Dave Brewer on air release valve chambers. And just a little bit about Dave. He's been involved with the waterworks industry since 1991. And he's worked with manufacturers in the underground water and wastewater markets in Canada in capacities ranging from inside sales to general manager. At Utility Supplies West Corp, he works with companies that include Smith Blair, H-Tech, US Pipe, Copperhead Utility Locating Systems to serve underground utility markets. These markets include public works, consulting, engineers, and contractors. In the past, he participated on the AWWA Standards Committee, including AWWA C219 and C226, and served 2 terms as president of the Municipal Services Association. So I'd like to welcome Dave. Thank you.
Thank you.
Sorry.
And away we go, day 2. Okay, so thank you for joining us this morning. And there we go. So, welcome to day 2 of the EOCP Virtual Conference 2021. So, today we're going to cover off eliminating confined space entry and air release valve chambers. And so, we're going to be talking about making the job safer for the operator to do the maintenance on the air release valves within their system. So what we're talking about is taking something like this and reducing the risk to the operator. So all the mechanisms involved in order for him to do that are no longer required. So first of all, we'll start off, why do we need air release valves? Or why are my wastewater lines failing? So properties of entrapped air. So why is this happening? So what's happening is you have air in your system, and we need to expel that air. And it can accumulate, first of all, unforeseeable water changes in water pressure, and this is what it causes. So basically, you can get pressure surges from the air pockets moving down the line rapidly, changing, and if you look at the picture on the right, we have a large air pocket that's constricting the air, the cross-sectional space in the pipe. That is going to restrict your flow. If those air pockets are dislodged and move rapidly down the line, what you're going to have is a water hammer effect. If you have that happen, you're probably going to have something like this happen. And this is a piece of cast iron that's out of the city of Calgary. And obviously there's other factors at play here. You clearly see there's some severe corrosion in here. Something like that is going to be exposed to the utility once that air is dislodged and stops rapidly. And it's going to expose your weakest link in your system. So we want to remove the air because we don't want this happening. So first of all, the solution, we need to put air release valves on your system. So there's just a really quick example of where you'd put these air release valves. At all high points, it seems fairly obvious, air rises. So we will have them at all our high points. All our secondary high points in the system. If we have a long run of rising pipe or falling pipe, roughly every 800 meters, we'd like to have an air release valve system. And certainly after pumps where the air can get entrained into the fluid, and we would like to move as much as we can at that initial stage of the pumps. Valves admit necessary quantities of air as well, so certainly in a wastewater system, we want to be able to admit air, or in a potable water system for that matter, or else we run the risk of collapsing the pipes. So at every point in the pipeline which is vulnerable to vacuum. So, and that can be determined by the utility, but you have to allow air into the system in some cases, and that's what an air release valve could do, a combination air release valve. The reliability and life of your automatic air and vacuum valve can be increased considerably by checking it for possible contamination and function at regular intervals. You got to do maintenance. Make sense? Maintenance should be performed after a period ranging from every 4 weeks to every 6 months, depending on the requirement of the valve and its given location. i.e. is this residential, where we're going to have standard materials in the line, or is this in an industrial park where you're going to have, a lot of aggressive materials going into the line that are going to clog the line up and consequently your valve. So that kind of determination needs to be made by the utility. All maintenance with the air and vacuum valves should be performed by personnel which are trained in both the proper procedures for the maintenance of the valve, but more critically and more importantly, how to safely enter a confined space. And so, and this doesn't matter where you are in what part of the country or part of North America, every utility has to have this procedure in place and essentially reviewed and signed off on before you're entering that confined space. As well as the operator entering confined space, there are other considerations for utility when implementing an air valve maintenance program. These include having a minimum of 2 operators for every maintenance visit. And in this case, you can see sometimes you'll have 3. Depending on what mechanism they have there, they might feel that it's necessary to have a 3rd operator there to remove the individual in the event of a catastrophe. Tripod and related equipment, so utility has to make the investment in this type of material. If they don't, they have to rent it. Specialty equipment such as trucks equipped with jib cranes, depends on how much you're being lowered and what you're being lowered into. That's also a requirement. And if you're a large individual, a manhole that the operator can fit into and perform the maintenance required in a safe manner. Over the life of an air valve maintenance program, given all of these requirements of the utility, operator can add a significant cost burden to a utility. So all of those things I just mentioned are costs that have to be accounted for by the utility in maintaining that asset over the lifetime of the asset. In some instances, a utility may not be able to meet all of the requirements, and as a consequence, the program falters. I've seen it many times where the utility just are not able to afford the resources required to keep on the maintenance of their system. If you don't do that, inevitably, it might lead to this. Again, at the beginning of the program, we talked about that air dislodging, moving down the line and exposing your weakest point in your line. So we want to avoid that if all possible. We want to have all the assets in the system working at peak performance as much as possible. So now we're going to talk about the options available to a utility so that we can eliminate these types of burdens. So options are available to utilities to eliminate the requirements of an operator to enter a confined space to perform maintenance for both water and wastewater. And that would be self-contained sets. Now, these are fairly new to British Columbia. They are starting to gather some momentum, but we have seen these used extensively in Alberta for some time. They're starting to get some use in Ontario as well. And they're a wonderful alternative for utility when they are challenged with having to, by WorkSafe, to reduce the amount of times an operator has to go and enter a confined space. So in this particular instance, we're seeing a contained polyethylene, the vessel is contained in a polyethylene encasement. The actual vessel is available, depending on manufacturer, either anywhere from 1 to 1.5 meters long. The air valve is removable with isolation valves located in the valve set, so no further valve isolation is required. So what we're seeing here is at the bottom, there's a knife gate valve or some sort of valve that is actuated from the surface by the operator that allows them to isolate this valve from the sanitary force main and remove the valve. Biggest thing, we've eliminated the requirement for confined space for the operator. There's no confined space required at all. All those additional materials and equipment are now not required for this particular maintenance. All of that reduces the cost of installation over the life of the valve. It is going to reduce the cost of that asset as well. And you'll be able to keep that asset working at peak performance without having all the burdens associated with the normal maintenance. So this is a HTEC 986 typical detailed drawing. But so we're coming right off the sanitary force main. We have a riser pipe cut to what a determined length you want. And then we go to the actual valve set. And it has a flange connection at the bottom. And it basically comes up to the surface with the manhole frame and riser and cover. And it's now brought to grade. We don't bring it right to the surface. We leave it just below the surface by about 8 inches. It could be a bit more if you like, but you don't want to have it too low where the operator is actually reaching down. But now everything, as you can see, can be performed from the surface. So here's an example of a wastewater set, and we're just going to walk through what it might look like in your utility. This particular one is from the city of Prince George. They've installed it in an industrial park. They've got a riser coming off the sanitary force main, which you can't see, and it backfilled back to the force main. And this particular force main has an insulation kit on there. Now, there is, when we talk about these with some utilities, they are concerned if you're in a very cold climate, such as Prince George, we do have insulation kits available for these, and most manufacturers do as well. And this is just to protect and guard against any kind of frost penetration you're getting into the ground. There's about a 2-inch wall thickness insulation that goes on the exterior of the valve to keep that frost from penetrating through into the valve body. So in this particular photo, a self-contained sanitary combination air release valve set, now backfilled to the surface with the manhole removed to expose the valve. And that yellow piece in there, most valves will have like a dust cap. And that's just to keep dust and debris from going in there. But again, easily accessed by the operator at street level. With the dust cap removed, the valve can now be isolated from the force main with the operator at ground level for inspection and any maintenance, required maintenance. So you're going to see on the left-hand side, there's a bar coming up with the square cutout in it that essentially is going to be what the operator uses to actuate the knife gate valve to isolate it from the bottom. There's a 3-way ball valve that is at the connected to the exterior encapsment. That basically is loosened, and the valve is then removed. They can put 2 hooks on it and pull it up with a rope, or if they have a jib crane, they could do that as well. But the valve can be easily pulled up, and any maintenance required can be done at that time. No confined space. So, just we're cutting away the earth just to give you a cross-sectional view of what this might look like. Just to kind of draw a better picture, the cross-sectional view of a sanitary sewer air release valve set coming directly off the force main. I say directly because I get the question quite often, I want to run this off a lateral. I do not suggest that at all for a wastewater system. Laterals can be trouble for a wastewater system just because of the solids that can accumulate in a lateral. And I, at all times, try to avoid that if at all possible, because if that lateral plugs up, you've got nothing going through the air release valve's not going to be able to do anything. Then you have to go back and you have to flush that out, back flush that out, try to clean it out. What we like is to have it coming directly in line off the main if at all possible. We're going to have a better connection to the valve. But more importantly, any kind of vacuum that's acting on that valve is also going to back flush itself and clean it out. Whereas a lateral is typically going to have a much smaller diameter pipe coming into it, and it's going to be very difficult for any kind of backflow or vacuum to work itself through that lateral should it get plugged or compromised due to grease accumulation or solids. So again, we're right off the sanitary force main. We can see the valve set. It's backfilled with a crush, and we have the manhole frame and cover at the top, which is removed, and then it's easily accessed by the operator. So that will just kind of break it down. This particular model here is one that we carry. We have the self-containment polyethylene encasement. We have the sanitary valve body. Now, one thing that's interesting, and I really want the operators on here to take note, when we look at a wastewater valve, it has a much different shape than a potable water valve. And that's for a good reason, because on a potable water line, you shouldn't have any solids in there. You shouldn't have anything other than water. But a wastewater line, you're going to have everything in there, I come to find. If you don't account for space in your valve, it's going to interfere with the mechanism. So it's very important that you make sure you have something that is suitable for wastewater. So I just want to make note of the body on that. We have an ample, in this particular valve, we have an ample amount of space in there. We have an air cushion, we have a debris screen and a debris trap. All of those mechanisms keep the valve operating in what can be a hostile environment with the solids in a wastewater line. That's your knife gate right there. So here we have a knife gate. To isolate the valve from the sanitary force main. Again, there we see the arm coming up, and a valve key can be put on that and rotated to isolate the valve. Then we have the 3-way ball valve that vents out into the annular space between the encasement and the manhole. We have a manhole frame and cover. And we have a valve to release residual pressure. You'll see this in a video coming up. It's very important that you have that, because even if it isolate that valve set from the sanitary force main, we still have a residual pressure in that valve that we need to vent out. So what that is, that's going to have a ball valve on it, and then we just open that ball valve, and there's residual pressure within the valve body that will be released. So this is going to be just a quick video showing how this maintenance typically would be done. Manhole's removed. Dust cap is removed. We put the valve key on there. We're going to isolate the valve body from the force main. Notice it's still charged. We still have that vessel charged with pressure. We now need to release. He's going to put a cam lock on there. And he's going to open the ball valve. And you're going to see the pressure go down. Now that valve has been de-energized. So there's no more pressure, residual pressure in the valve. Next thing we're going to do is, it's just the loosening of the nut that connects to the encasement. This is a bayonet fitting, so you just twist. We hook on 2 hooks. In this particular case, he's got 2 ropes, and he pulls it directly up. You're going to notice in this, when he pulls it up, we have material in the valve. There's going to be material in it if it's been energized. There's a residual material rolling out, coming out of the valve. These encasements, that is going to have a drain cock going back to nature. You can't really see in this picture, but there's a drain cock that goes to the bottom, and all of that material flows back to nature. So now the encasement doesn't have all the contaminants from the valve sitting in there and accumulating. It drains back to nature. But as you can see, the valve's been removed, easily removed. All the maintenance required can be done up top now. Where it's removed from the ground, the operator can quickly perform an assessment on what amount of maintenance is required on the air release valve. This could be a simple cleaning on site with reassembly. In this particular case, the valve's been removed, and it's just a simple pressure washing to remove some of the residuals and grease off the valve. Excuse me. Or if a more involved situation is required, then the operator would bring the valve back to the works yard for a more in-depth cleaning. Or if you're planned out enough, you've worked with your local valve rep company, and you've brought spare parts to site. So you just exchange the parts and bring whatever parts you've taken out and bring them back to the yard for maintenance. And this is just a case where clearly we have an issue. This is full of wastewater. One of these valves is failing badly. So that'd just be an instance where you're probably not going to be able to fix on site. This will have to go back to the shop for more maintenance. So that's it for wastewater. The other thing that's available, these are both available in potable water or wastewater. In this particular one, this is one for potable water. Riser is in stainless steel, so it's corrosion resistant. Good for cover from 0.8 to 2.44 meters. Removable under pressure, just like the wastewater valve. Again, all the maintenance that is going to be performed is going to be done from the surface. Now you're going to notice something on here, and that is and this is just a detailed drawing. We have one that says valve directly over the main. So we've come directly off the top of the main. However, the one on the other side says valve offset. On water, you can run a lateral. I would be fine with that because, again, it's just water or air going through there. There's no solids. Again, I see this quite often where utilities will be running. I've seen laterals run as small as 3/4 inch on a wastewater line. It's not going to do anything. It'll plug up right away. But on a water line, you can do it. Again, just like the wastewater one, if we're working with water in a cold environment, this is in southern Alberta, colder climate for sure than where we are in the lower mainland, we can put an insulation wrap on the outside of the valve body so that if there's any frost penetration, it's not going to negatively affect the valve. The self-container release valve set, once installed, is covered with a simple meter box or meter box pit or manhole. Either manner still allows easy access for the operator. So again, doesn't matter, we're still bringing it to the surface for the operator to grab. This is just a really quick video of showing somebody perform. This is actually with UBC Endowment Lands Utility and the boys there. We came out there for a quick maintenance, but it's a bit more involved as far as isolating from the wastewater main, but the potable water is very similar. It's that we're going to isolate everything from the top, and here he's going to remove the dust cap. Well, it was supposed to play a video there. The centering screw is loosened. So in this particular case, it's a little different. We have a centering screw and a yoke that acts like a brace to keep the valve in place while it's under pressure. Let's see if the video works here. you able to toggle it on your end? Just click on the actual picture itself and see if it runs. Yeah, it's not working on that, so you should be able to just hit the play button. Okay. Well, we use your theater of the mind, everyone. So in this particular case, like I said, the centering screw is removed and that yoke bar is then removed. And what that does is that's going to just lift the valve a little bit, and you get a little burp of water coming out of there. And that's because the self-sealing tappet valve at the bottom has closed up, and now it's sealed off completely from the main. And then what's happening here, again, and again, it's water. We don't have remember how I said on the wastewater side, the valve bodies are much different. This is, it's unfortunate we can't see the movie, but in this particular case, we have a body, the valve body coming out, and you can see it's way smaller than a wastewater valve. I don't need to have a big valve in that particular manner because I'm not having to account for any kind of solids that are going to be in the body. So in this particular case, it's a streamlined valve. And its only purpose, it's a stainless steel valve in this case, so it's never going to corrode. It has polypropylene internals, so they're not going to corrode either. But the operator is all at grade level performing this maintenance. After the inspection of the valve, the valve body is now ready to be installed back into the self-contained chamber. So again, we don't have video, but in this particular case, it just slides it back in. And then he's going to do the nut back up. In this particular case, the yoke's put back in, that centering screw is then tightened, and it's going to push the valve. And it's really interesting here, you can see there's as it's entering into the live main again, there's a bit of a noise. You can't obviously hear it, but in this instance, that's when you know the valve is back, sealed, bowled back in line with the water main. In this particular job, we were directly installed in line. There was no lateral involved. But again, there was no additional isolation required. Some utilities like to have further isolation, like a bit of redundancy, so they might throw a curb valve just before on the lateral coming into the valve. In this particular case, the valve has capabilities to be fully isolated from the water main by the topping valve at the bottom of it. Again, all done with one operator. This is just, this video should play. This is just a real example, get a cross-sectional view of what the operator is doing. So again, dust cap's removed, and as you see, he's going to take a ratchet and he's going to loosen that centering bolt that lifts the yoke. And you can see the valve lifting, and that's the self-sealing taplet with the water pushing it out. And as he pulls that valve out, there's going to be residual water left in there. And that has a drain cock in it as well, and that drains back to nature. And now the valve is now ready to have whatever for inspection or maintenance that might be required. So very simple, just again, wastewater, wider, bigger to accommodate the solids, potable water, narrower. So, but it's very key because I see utilities sometimes using the same valve that would be working for a water line, use that same valve on a wastewater line. And they say, well, it's meant for wastewater because it has stainless steel internals. Well, fair enough. I get that. You have a corrosive environment, but you haven't accounted for the larger solids that are going to be in that wastewater line that could very well interfere with the way that valve performs. So it's very important. I just want to make that note. In this particular case, obviously, in a wastewater system, I'm not so worried about being in a floodplain. I'm not going to get cross connections, but in potable systems, you have to be concerned about that. And if you're in a self-contained system that you have a flood event, which we're now having to account for in this day and age, we can do what's called the flood protection kit on the self-contained sets for potable water. So in this particular instance, we got basically, for lack of a better word, a snorkel that goes over the valve body at the top. Venting channel via slots in the stainless steel shaft. So you can see there's channels cut out into it. That's where the venting is done out of. Waterproof gaskets in the lid and lower part of the body, so there's an O-ring packed around it that forms the seal against the exterior of the contained set. And this particular one is waterproof for up to a 5-meter water column. So if you had a flood event where you had 5 meters of cover of water, this would have the capability of keeping any contaminants from entering the valve body. And this is just kind of a cross section of where you'd see it. Obviously, you're going to run a line coming off the vent to off the flood protection kit, and candy cane it out to a higher section so it can both vent and vacuum without drawing contaminants into the system. So this is probably the most popular questions I get. Yeah, but I bet they're real expensive. Remember at the beginning of the slide, we don't just take the valve body or the valve itself into consideration. This asset's supposed to be lasting years, long time. So all of that is going to add up. So certainly when an air release valve is achieving multiple tasks such as venting, vacuum, and being able to accommodate direct bury, there are going to be features that add cost to the fitting. There's no doubt about it. It is more expensive. So when comparing against traditional air release valves, all factors have to be considered when we're making that comparison. And it's not as much as you might think once you take these into consideration. But this being said, all costs need to be compared fairly against one another that achieve the same result. With self-contained sets, utility can eliminate the need to excavate for a large excavation for a manhole. You don't have to have as large of an excavation. The actual manhole material and labors to install, that can add up. Well, can you actually, a good point right now, and I'm sure a lot of the utilities on this presentation right now, can you even get them? Can you get your manhole risers? Can you get your lids, your frames? Anybody that's in the know that materials are terrible right now. So that's a challenge, as well as adding up those costs. The biggest one is the future cost of equipment and labor for maintenance. And this is the one I really emphasize for utilities to take into consideration, is that, it's not just the moment you've put in that we're comparing the cost. All that equipment you need to go into confined space entry, all the labor that you need to have on site to do that confined space entry, what is that going to accumulate to over the life of the valve? And how does that compare when we just have one individual doing the maintenance? All of those need to be taken into consideration as well. And above all else, it's safety. The individual is going to have a much safer environment to work with than having to go into the manhole. So I do ask that the utilities can take that into consideration when looking at their manhole and their basically the lifetime of that asset and what it's going to cost you to operate. But all of these costs are added up over the life of the valve. The upfront cost of the self-contained set is not as prohibitive as initially thought. Allowing the utility to eliminate the confined space and allow an easy means of maintaining the air release valve in the future can go from this. In this particular instance, we can see we've got an air release valve that's failing, and it's spraying contaminants in the manhole. Just not a fun environment for any operator to go into. To something that's much more streamlined and easier for the operator to work with, that's actually makes the job less daunting, and it will actually get done. So, confined space entry is a challenge at the best of times with utilities having to deal with multiple examples on a daily basis. With the evolution of air release valve sets, these requirements can be at the very least reduced, and in some cases eliminated altogether. This allows for the operator not to be exposed to unnecessary dangers and allow for a utility to have the distribution system working at maximum efficiencies, and avoids instances like the team building these two guys are trying to do here in this slide. In any case, that's it for myself today. I'm now available to answer any questions if there are any out there. Do we have any questions? No? Okay. Sorry? There are?
Thanks so much, Dave. That was excellent. I always, as an operator, I always appreciate when confined spaces can be engineered out. This makes the work so much easier.
They work. They work. And then once we get them in place with some of the utilities, they just kind of marvel and like, that's it? And I'm like, yeah, that's it.
Just so quick, and it doesn't involve a team of 2 or 3 or...
Yeah, and everybody goes home at the end of the day.
Exactly, that's the most
important. That's the most important thing.
I'm just stalling you a little bit while we get our questions organized. I'm just going to read them to you over here.
Shall I do a dance here? Or?
That would be fun for everybody. Sure, can I read off there?
I think that looks like chats.
That's right. I'm in the question and answer section. If the valve needs to come back to a shop for more in-depth maintenance, is a cap/blank provided for further protection
Oh, that's a good
over and
question.
above the gate valve in the event of a gate valve
Sure.
failure?
Short answer, no. But it is, we have spoke with some utilities and have looked at, if we have to, it's not very difficult, and I'm going to speak specifically to my valve body now, okay? In those instances, we would actually take the internals out of the valve, and we would put a blind flange over the top of the valve body, and then just bolt it back up with a gasket underneath there, and that would isolate. So if they couldn't do what they needed to do, or if the knife gate for whatever reason wasn't working, which shouldn't be an issue, but I know how this world works, and sure enough, as I say, never, it's going to happen. That was a solution that we'd come up, because a similar question had come up from the utility that I was dealing with at that time, and we had made the determination we would just put a blind flange over the top of the valve body. The internals come up. The valve body should be fine. The valve body is going to be the most robust piece there. The blind flange over the top of that. You wouldn't be venting or vacuuming, but you would certainly have it sealed off in case there was any issues. There is a flange available at the top, the covered off blind flange. I hope that answers that question. Was there another one? Okay. What a
Yeah.
lateral. Should I just read them from the top here?
Oh, excellent. I didn't know if you could see them.
I can. Wonderful. Would a lateral on a gravity outfall line from a wastewater treatment plant be okay? I get nervous about laterals. I've worked with laterals successfully. I've also been unsuccessful with them. I think I would like to have a dialogue in a particular application like that as to what are we pulling the lateral off of? Are we pulling, and I'm not speaking specifically to this here, but are we pulling a 2-inch lateral off a 6-inch main? That's going to be a problem. In my experiences, it has never ended well. It has become plugged up, and just the flows between the two have not been as positive as we would like. Do you have let's say a 400 line and you want to pull a 150 or 100 lateral off of it? I think we might be able to have successes in that particular instance. What I would suggest you do in those instances is just reach out to your valve manufacturer or myself. My contact information will be at the end of this presentation, and we can dialogue on that and tell you what our successes have been. Does the force main connection? Oh boy, does the force main connection need a thrust block? So where we're tying into, I'm assuming this individual is saying when we tie in off the force main with either be a T or a tapping sleeve, is there a thrust block? You know, I don't think it's bad practice. That's actually a good question. In my experiences, I have not seen a thrust block applied where we are making a connection. I'm going to speak in line. I'm not going to speak specifically to our lateral. I'm speaking where the valve's been installed in line. I have not seen a concrete thrust block dropped. Keep in mind, we're typically working with lower pressures, and I have seen both ductile iron T's or T's used where we're coming up vertically, and I've also seen tapping sleeves used. I know from the pressure side of the world where I work on the waterworks, you absolutely would do, because we have essentially a change in water direction or column. But not with an air release valve. I have not seen those done in that manner, because I have to think we don't actually have a flow going through the valve of fluid. It's essentially, it's a cushion, it's sitting there, but it's not a major directional change for the material, because it's not flowing through the, ideally, it's not flowing through the valve in a continuous manner, where it could be subject to a moment or a hammer, which would catastrophically put stress on that T. I have not seen concrete thrust blocks used on air release valves in that manner. I want to clarify that comment on sizes, typically from, let's say, 1 inch up to 4 inch. If we're going to get into sizes above that, that might be different and merit more consideration. How are you accommodating for frost and heaving when there are lateral pipes connected to the devices? That's a good question. I'm going to come back to the wastewater side, and I'm going to say my job would be to deter or discourage you from using a lateral on a wastewater system to start with, and certainly, but on a water line, certainly in Alberta they get frost depths up to 8 feet, And I would suggest if they're running it off a lateral, what they're probably going to do is snake the line so that there is enough material there. So should the ground want to go up, or in a drought condition, go down, that you have enough material there to accommodate the movement. If we're in a like a clay soil, which is really subjective to heaves up and down, such as you might see in Manitoba, then special consideration will have to be done in your design. It's not going to only affect if it's in line the T or the tapping sleeve where we have that air release valve. It's going to affect your whole pipeline, and if you have that much movement, special considerations should be put into your design to accommodate that. They have slip joints that allow the expansion and contraction to be taken up. But it's a good question. But I have not typically seen that being an issue where the let's say in this case it's a lateral on a water line, where the lateral is pulled out, and I'm going to have to assume that they've accommodated with the snaking of the service tubing to allow for that material to expand and contract. Are there sump pump capable options for these self-contained valves areas with non-permeable drainage? That's actually an interesting question. Non-permeable drainage. I would say yes. Yes. And it's only because I'm dealing with it right now with a utility up in northern British Columbia where we're using the valve set you saw in the presentation. And in this particular instance, they're using that valve set. But the utility did not want to have any kind of residual materials drained back to the surrounding area. Backfill, they just wanted the backfill to be kept pristine without any materials flowing back into it from the wastewater system. In that particular instance, we're actually designing on the drain port at the bottom a connection that takes it and pushes it back in further down the line back into the sanitary force main. So if there is any residuals that come out of the valve into the containment vessel when we remove it, theoretically, they come into the vessel through the drain cock and then drain back into the force mains at another location. I hope that answers the question, but please reach out and feel free to contact me so we can discuss it further detail. But that's an interesting question. Some good questions here. I think the building into an existing system is lengthy as opposed to new construction. I would agree. Is there any tricks you could share for building into an existing system? Absolutely. That's actually a great question. Everything I've shown you here is, you're right, it's basically meant for a new construction. We have seen these go, I have installed these on existing mains. That's been mostly water, but the wastewater has been on new construction. With that being said, I can speak specifically to myself, but I believe there's another manufacturer that has this as well, is that we can take the valve body and the knife gate isolation assembly, remove the isolation containment vessel, and install that directly into a manhole, and then backfill with rock, so that that same vessel in a manhole could be assembled and removed. Actually, you wouldn't backfill the wastewater one with rock. It can be put into the manhole. You'd have to support it because there is some weight considerations. It's not concentric to the main, and that could be easily rotted off the manhole. But you would bring a riser off the manhole, depending on how much you had to bring up to grade. And that same valve in the encasement can be used inside a manhole, and now the individual just removes the manhole and that valve can be accessed from street level. And again, I didn't include this in here, and that's actually a good point. I probably should in the future, but that has been done. We have done that. So that's a great questions here for these people. Great. Is that it? I think so. Oh, sure.
Over here, sorry. Where are you based out of, and how are regular parts? What's the availability?
Sure. Myself personally, our shop is based out of Langley, British Columbia. I personally just moved up to the interior British Columbia, and I'm loving it up there. But I cover British Columbia to Manitoba, so there's no place out there I can't get to. Parts are, I have to speak specifically to my valve set. Our valve parts are kept in Langley, British Columbia. Or if we don't have them there, then we would bring them out of our partner's location in Marietta, Georgia. In my experience, we haven't had somebody out of parts more than 10 days. And most of the utilities that we work with, we're pretty proactive in making sure far before they get to that point that they have redundancy in parts should they need be. So.
Just a note for everybody, Stephanie put your contact information in the comments, and so maybe you have a website address?
Oh, I do. Ask me to remember that.
Well, email
Certainly,
you.
yeah. I think if you were to put in USC, just USC West Canada, our company would come up in a Google search pretty quickly. So at least I hope so.
One last question for you, Dave. This person may have missed this, but are there corrosion issues with the wastewater valve sets?
Yeah, that's probably my favorite question. There's always corrosion. I mean, we have H2S in there. Most, again, and I really want to emphasize this with the utility operators out there, and I see this in British Columbia in some of the more heavily populated areas, is that they're still using the air release valve that was meant for potable water. The first thing you need to know is in a hydrogen sulfide environment, if you don't have a gasket that has been specially equipped to deal with that H2S, it's going to eat that gasket over time. So you're like, well, I have to replace the gaskets every so often. Yeah, you do, because it's the wrong gasket. So yes, you have to have the right valve. The manufacturers that I'm aware of that take these into consideration do not have an issue on corrosion. So in that particular instance, I would say that is not a concern. The valve sets that I showed you today, one of them was steel-bodied with epoxy coating. Obviously, that's an economical choice for the utility, but they're also available in completely 316 stainless steel. So it'll be there long after everybody on this presentation is retired. So it depends on what budget and what the economics are for the utility to work with, but as long as you're choosing the sewer valve for that application, and it has the proper mechanisms in place. And don't forget about the gaskets. The gaskets are typical gaskets are subjected to hydrogen sulfide. I believe we do use an HNBR, which is resistant to the H2S that is normally found in the wastewater system. That most definitely will deteriorate your gasket over time. So, and that's that. That's fine.
We just put in your website. It's www.usccanada.com.
Yeah, that's a real hard one to remember, right? It's
Great
just in my
presentation.
favorites. I just click it every time. It's right there. So.
Exactly. When you go there, Google knows where you're going.
Yeah.
Thank you so much, Dave. That was an excellent presentation.
A great group of questions too, though. So, okay, thank you.
It's a better.